Eric's Guitar Amplifier Repair, helping musicians to perform better. Welcome to Eric's Guitar Amplifier Repair here in California. My name is Eric. Today on the test bench we have a Fender Deluxe Reverb, highly modified by my mentor Lee Jackson. Customer complaint is that the amplifier is cutting in and out. This may be due to a bad tube. That's his. Those are his thoughts on his personal amplifier. So we'll put it on the test bench and we will detect the problem. Let's begin. Okay, we're looking at the 6v6 tubes, and we can see that the silkscreen looks pretty good on this side. As we look at the silkscreen on the front, it looks like it's been running pretty hot. This is normally a purple color. Now these 6v6 tubes are about 3 years old. The owner of the amplifier has a tendency, he believes that if he leaves it on in standby for 3 hours, that improves the sound. I'll let the other technicians out there comment about that. The left side tube tested bad, and when I mean bad, it didn't even register on the tube tester, it was just gone. Looking at the plates, you can see here on the left, the bad tube, you've got this indication of this maybe red plating. Okay, so something's going on in the circuit. Now this is a Deluxe that is extremely old. It was built in the 1960s. On top of that, Lee Jackson went in and did his thing to the amplifier, and now it's no longer a Fender Deluxe, it's a Lee Jackson highly modified amplifier. So we need to go through the whole circuit board. We need to check that the bias circuit is still functioning properly and that all the resistors are in tolerance. My knee-jerk reaction just by looking at the tubes is to verify that the grid resistors going into the output power tubes are within spec, and maybe just change them out to something that's more robust. A higher wattage is my knee-jerk reaction there. Of course, the bias, we want to verify that that's fine. We need to check the plate voltages. So I believe from recall, the plate resistors are the carbon composition type, so we may need to replace that, and probably we'll use a military type resistor by Holsworth. We'll see. So I do need to pull the chassis. This is not one of those replace the tubes, bias, and then just go. Something's going on within the circuit, and that would be very normal. Very old amplifier. As you look at some of the components, it's been really monkeyed around with by other technicians. Things have just sort of been swapped out and then put low grade, well, everything. You'll see this in a moment. So we're going to take care of all of that. We're going to replace everything that is low grade to the proper Fender standard, and just kind of go through everything, the wiring, and just go through the whole circuit board. And then of course make sure that the circuit board itself isn't saturated with moisture, which is common for an old amplifier like this. So let's move on to the next segment. Alright, we're looking at the top side of the enclosure of the Fender Deluxe. You can see here, this has been signed by Lee Jackson, 1985, and then you have Lee Jackson's card here, his Metaltronics Custom Design Shop, 1985. Lots of preamp tubes that have been added here. Most of these preamp tubes are for the effects loop. And then he has the tube rectifier replaced with a diode type rectifier thing, which I'm going to show you right now, so please hold. Alright, here we have this aftermarket device by Groove Tubes, and this is, within this is a circuit that just has diodes as the rectifier. So this is the rectifier tube socket, and you have this. So this preserves the ability for someone to take this out and then put in a rectifier tube. Now I don't know if there were other modifications in the circuit to deal with this diode, but we'll take a look at that as well. It's kind of wiggly in there, isn't it? Look at that. So that might be causing some problems. We'll take a look at that. Alright, this is the circuit, and you'll see in a moment all these modifications. This looks like this was done by me. Like I said, I serviced this about 3 years ago. Everything looks fine. We have a carbon composition back here. Visually it looks good. We have the original diode. We'll test for that. I'm sure it's fine. We have all of these smaller wattage, what are these, half watt resistors here, so maybe we can boost that to a higher wattage, but I won't just replace stuff unless it really necessarily needs to be replaced. Let me see if I can slide this over without jerking the camera too much here. Let's move this out of the way. And you can see here we have all of this highly modified. This is a what is this? This is a selector switch with different capacitor values and resistors as well, it looks like. So this is one of his sort of famous modifications, his being Lee Jackson. Here you can see paper analog capacitors. This was done by me 3 years ago. Solon capacitor here, also done by me 3 years ago. These are all orange drops, and as most people know, I cannot stand orange drop capacitors. They sound horrible. I just don't like them. On our right we have this ginormous Mallory electrolytic capacitor here in this part of the circuit. So I don't know if this is just something he had laying around and he replaced that. It's not like Lee Jackson to do that. He likes to use the Sprague and Adams that I showed you in the previous segment there. So I'd like to get rid of that. I'm confident there's nothing wrong with this, but it's an old capacitor, and they leak electrolytic paste, and since I'm in here I might as well replace that. Let's see if I can scoot over a little bit more. So the plate resistors have been replaced by either Lee Jackson or somebody else. So we'll test the values, but those should pass okay. You've got all of these different capacitors all over the place, and yeah, this has just been highly modified so much. It's really something else. But we'll go through everything. I think as I look at this, I haven't tested anything yet, but I feel like maybe we just need to bias the tubes, the new tubes that I have for this amplifier. We'll bias it a little bit cooler, and I'll show you how I do that using an oscilloscope. But let me go ahead and do a full visual on the circuit and then test all the components, and I will test everything. Every resistor will be tested and then replaced if necessary. I see something that right now that looks like it might be a little burnt, and I'll point that out after I verify that. Okay, let's move on to the next segment. Continuing down the circuit, you can see that this is again just super highly modified circuit. You can see that the electrolytic capacitor that I mentioned in the previous segment has been replaced with an FNT type electrolytic capacitors. I do like these electrolytic capacitors designed in Germany. This is a 22 microfarad electrolytic capacitor rated at 500 volts. Alright, looking at the bias circuit, the diode passed test. The 470 ohm 1 watt resistor also passed test. This Spragg & Adam capacitor was replaced by me 3 years ago, and this also passed test. The circuit, this bias circuit, has been modified by Lee Jackson, and we can go over that in a moment. Looking at the two 6v6 output tube sockets, we have this 500K grid stopper resistor. This test passed. This passed. 1.5K here at the grid as well. 1.5K passed. Alright, looking at the coupling capacitors from the phase inverter to the 6v6 output power tubes. I originally had put in paper and oil coupling capacitors at 0.022 microfarad. I replaced those with this 0.1 microfarad because I want the amplifier to sound closer to the original Fender Deluxe circuit design. The customer is a blues-like, funk-like style player. He's not a heavy metal guitarist, and so we want to replace these coupling capacitors to be closer to the original Fender Deluxe circuit design. We see the classic Lee Jackson Selector switch here. These are different valued capacitors, and this is his classic mod. And finally, we are at the beginning stage, the preamp first stage of the circuit. Again, you can see this highly modified circuit. Lots of orange drop capacitors here and different types of resistors, but that's fine. There's no problem there. We'll look more at other sections of the circuit, the effects loop, so on and so forth, so we'll take a look at that right now. Alright, we're looking at the filter pack. We have 16 microfarad, 60 microfarad electrolytic capacitors replaced by me 3 years ago. I like these F&T capacitors. And then we have some high value capacitors here, 220 microfarad here, 220 microfarad here, and another high value electrolytic capacitor here. So this is another mod. This is not what the original Fender Deluxes have. They're much lower microfarad. So that's just something I wanted to show. Again, these types of Mallorys tend to leak electrolytic paste. You can see that little bump there. So this one's just starting to fail. I'm going to leave these capacitors in. I think they're still have a little bit of life in them. We can squeeze out one more year maybe. Really should replace these because they have a lifespan. All electrolytic capacitors have a lifespan, but I don't want to have to. I don't have these values in stock, and I don't want to have to order this and then charge my customer money to do that. He just wanted to get his vacuum tube replaced, and then he could be on his way. So unless when I turn this on and run my final test and run the 1 kilohertz sine wave, if I see noise in the sine wave, then yes, I will replace these. There's no choice, it has to be done. But otherwise, we'll just leave this alone. So I'm going to go ahead and put the vacuum tubes in and start making the bias adjustments. Okay, we're looking at the 6v6 output tube sockets. We have one of my digital voltmeter leads attached to pin 5 of one of the 6v6 sockets. Now, because through visual inspection I felt that there was a red plating incident, and what that means is red plating just means that that particular tube or both tubes are pulling too much current. If both tubes are red plating, you know that there's something going on in the bias circuit, so you want to check there first. If you have only one tube, like in this case, red plating, you want to check all the components around that socket and then everything attached to, you want to go upstream and check the components, make sure they're all testing and functioning properly. Now, before I turn on the power after installing the new tubes, before I do that, because I have a suspicion that this was a red plating incident, the first thing I want to do is make sure that the pins are all tight. So tighten all the pins, both sockets, but the offending socket is, you want to focus on that. Of course, you want to focus on that because that's the area that is red plating. So take care of the pins there. You don't want to turn on an amplifier, brand new tubes, and then you're red plating that brand new tube and you're destroying that tube and you're wasting time and money. So don't do that. Make sure everything is functioning properly. Make sure the pins are tight. You were going to look at pins 4 and 5. Those are the grid pins, so you want to make sure those are tight, but tighten everything. Just make sure everything's tight. When you're ready to power up, please use a variac. Bring up the voltage slowly. Observe the tubes. Make sure they are not red plating. If you see that they are beginning to red plate the offending tube, shut the power off and then go back and investigate. But I'm confident that if seeing that there's probably just one tube that's red plating, doing everything that I explained, making sure everything is functioning properly on that offending tube, you're going to be fine. Bring up the voltage slowly, observe the tubes, make sure they're not red plating, and I am confident you're going to be successful. Now, again, I want to emphasize, if you see red plating on a vacuum tube, all of that means is it's pulling too much current and something is going wrong within that part of the circuit. So that should be easy to fix. Red plating is sometimes very difficult for certain technicians to diagnose, but it's not at all. It's fairly easy to fix. So let's go ahead and move on to the next segment and make sure that our amplifier is working properly and that we don't have any red plating incidents anymore. Okay, we have installed the 6v6 tubes and their output sockets. Brought up the voltages slowly on a variac and observed the tubes, and there is no red plating anymore. So we will do a hard test in a moment, but I wanted to show you the bias pot here. We have 3 terminals, and you want to put your positive lead on the center terminal. Like so. And you want to see a negative voltage of 35 volts. So I believe with the 6v6, you're looking for negative 28 to negative 35. So low end is negative 28 and the high end is negative 35. Now, once you get that negative bias voltage, I will show you how I do the final test and the final bias using oscilloscope, but I just wanted to point that out, just show you where you want to put your lead. Side note, I know that lots of people like to use a specialized tool to measure the currents and to modify the output tubes with a resistor to ground, so on and so forth. I just don't see that as being super necessary. It's dangerous. It's a dangerous test. There's a very great capability of shocking yourself or damaging your test equipment. It's just a dangerous method. There's really no safe way of doing it, so I'm not even going to get into that. I like to look at what the design engineers ask the technicians to do, and that's in the usually in the schematic. So we're going to not get into the current measurement. I think I really feel strongly this is the proper way of biasing an amp. And again, the final bias will be done using oscilloscope, and I'll show you that next. So here we are observing the behavior of the 6v6 tubes. These are brand new tubes, and we're looking in this area here, and then on the back for red plating. We can see that there is no red plating on these brand new 6v6 tubes, so that's really, really good. Now, many of you out there might be asking, why didn't I show the tubes red plating so that you could observe what that looks like? And the reason is because you never want your amplifier to go into red plating. The output transformer is attached to these 6v6s, and if this tube is pulling too much current, and that's what causes the red plating, you got electrons slamming into these plates, you are going to destroy your output transformer. Again, let me repeat that. You will destroy the output transformer. Now, this amplifier is dated around 1965, 1966. So you have to ask yourself, do you want to destroy your amplifier just to see some red plating? Yeah, probably not. So don't let your amplifier ever go into red plating. If you absolutely feel like you must verify that your amplifier is red plating, go ahead, put it on a variac. Bring up the voltage, observe the tubes. If they red plate, turn it off as fast as you can. Turn it off right away. And then you can go back and check to see if something's going on in the bias circuit, so on and so forth. Now, I get a lot of amplifiers coming in from clients who may have taken their amplifier for red plating, and the tech says, oh, I replaced all of these components. The red plating is gone, just to find that the red plating is still there after a few hours. The amplifier goes into red plating maybe after being on for an hour or so. And again, this is due to the fact that the tech is not paying attention. You need to check the tube sockets, especially in an old amplifier. Even in a new amplifier, you want to check that the tube socket pins are tight. They need to be tight. They need to make sure that this is not wobbling around, this tube. If it's not making correct contact and at the wrong pin, you're going to have problems, and you're going to have techs scratching their heads. They can't figure out, after replacing a bunch of components, why it's intermittent red plating. They give up, and they go through all of these steps to try to figure out what's going on, and it's a pretty simple thing to look for. So you always want to check the pins first. Okay, so I'm going to go ahead and show you the sine wave test to get the bias right and dialed in perfectly. So let me move on to that section. Okay, we are in the throes of the final bias adjustment. I have the bias set at negative 35 volts, and we're going to bring up the master volume. And as I bring up the volume, we're going to push this into clipping, and we can see a nice clean sine wave there. And here we are clipping. I'm at the top end of the volume control, which is around 9, and we can see this crossover distortion here. And so I may pull the negative bias voltage down a tiny bit. We're right at the top end of the volume, so this might be okay. We can see that we have a nice even balanced clipping here. That's what you want to see. We have a balanced output tubes, so that's good. So we're done. Alright, let's take a look at this Fender Deluxe Reverb, highly modified by Lee Jackson of Metal Electronics, amplification. Looking at the first section of the front panel, we have the reverb, which has been moved over here. We have our volume, treble, and bass. This has a higher output section here, and it's a brighter section than the previous circuit design. Sounds fantastic and very bright. Moving on to the next section of the front panel, we have our one input, gain, volume, treble, middle, mid selector. So this is a mid selector. Let me come up from the top here. So you can select different tonal characteristics here. So this is just a selector switch that has multiple different capacitor values using orange drop type capacitors. So that's a very classic Lee Jackson mod. And I was using this type of mod too. I was taught by Lee Jackson how to do this in the 2000s. That's when I met Mr. Jackson. We have bass, and then we have a master volume. And then we also have, let's see, this middle is a push-pull type, and that's a boost. That is a boost. Pretty neat. Let's take a look at the back side of the panel, and you'll see the effects loop and some other features. So let's take a look at that. And here we are looking at the back panel of this Fender Deluxe Reverb, highly modified by Lee Jackson. Line out. We have our effects loop section here, return, our volume, send, volume, presence. So we have negative global feedback. That's something you would find on a Marshall. And various input and output jacks. Pretty neat. And then you can see down here we have a section that's been modified. So this is the tube used for the effects loop. Pretty neat. Lee Jackson. And then I wanted to show, this is the Lee Jackson foot switch. It's pretty cool. We have a reverb and boost, and this is how the jacks appear. So let's bring that into the shot here. 1, 2, 3. This is the end, the other end of that boost and reverb stomp box. Pretty neat. And let's take a look how this is all attached here. So it kind of goes along like this. And then we have this cable, and then it splits off like that. So some shrink wrap electrical tape. Yeah, so this is pretty interesting, pretty neat. Again, this is modifications from 1985, so that gives you an idea of how long we technicians have been modifying amps. This is pretty cool. And that's it. So we'll wrap up this video. And yeah, Lee Jackson, pretty awesome. Eric's Guitar Amplifier Repair, helping musicians to perform better.